Example number 11. So that the function f from R to R defined as f of x equal to x square is neither on1 nor on2. Solution. First going to prove f on1 then on2. For on1 1 to 1 for 1 to 1 let 1 belongs to R in the domain f of 1 is equal to 1 square equal to 1 belongs to R in the codomain, and let minus 1 belongs to R in the domain f of minus 1 equal to minus 1 square is equal to 1 belongs to R codomain. Therefore 1 is the image of both 1 and minus 1. Therefore f is not 1 to 1. Next for onto let y equal to minus 2. Y is equal to f of x square is equal to minus 2. That is x square equal to minus 2, x equal to plus or minus root of minus 2 not belongs to R. Therefore minus 2 belongs to R is not image of the image of any element in R. Therefore f is not onto. Hence f is neither 1 nor onto. Example number 12. So that f from n to n given by f of x equal to x plus 1 if x is odd, x minus 1 if x is even. Is both on and onto. Solution. Case 1. If x1 is odd and x2 is even. Now f of x1 equal to f of x2, which implies x1 is odd. Therefore x1 plus 1 equal to x1 minus 1, which implies x1 x2 plus minus equal to x2 minus 2. x1 not equal to x2. Therefore f is not 1. Next case 2. Let x1 is even and x2 is odd. F of x1 equal to f of x2, which implies x1 minus 1 equal to x2 plus 1, x1 equal to x2 plus 2, which implies x1 is not equal to x2. Therefore f is not 1 to 1. Case 3. Both x1 and x2 odd. F of x1 equal to f of x2, which implies x1 plus 1 equal to x2 plus 1, which implies x1 equal to x2. F is 1 to 1. And both x1 and x2 are even. F of x1 is equal to f of x2, which implies x1 minus 1 equal to x2 minus 1, x1 is equal to x2. Therefore, f is 1 to 1. Both odd or both even. For onto, let 2r plus 1 belongs to n be odd. Then f of 2r plus 1 is equal to 2r plus 1 plus 1. 2r plus 2 belongs to n is even. Let 2r belongs to n be even. Then f of 2r is equal to 2r minus 1 is belongs to n is odd. Therefore, f is onto. Since every image has a pre-image, all even numbers and all odd numbers separately have the pre-image. Hence, f is 1 1 and onto. Example number 13. So that an onto function f from set of 1, 2, 3 thence to set of 1, 2, 3 is always 1 1. Here given solution, given f is onto. Suppose we assume that f is not 1 to 1, hence two elements 1 and 2 in the domain as the same image in the codomain, and the third element 3 in the domain has one image in the codomain. Therefore, the range set can have at most two elements of the codomain 1, 2, 3. Thus, one element in the codomain has no preimage. Therefore, F is not onto. It is contradiction to the given F is onto. Therefore, it is impossible. Therefore, F is always 1 to 1. Example number 14. So that an 1 to 1 function f from set of 1, 2, 3 thence to set of 1, 2, 3 must be onto. Solution. Since f is 1 to 1, therefore 3 elements of 1, 2, 3 must be taken to 3 different elements of the codomain 1, 2, 3 under F. So each assign each free image, separate free image. Therefore, F is onto function. Is a onto function. Some remark. One, an 1 to 1 function f from x to x is necessarily onto for every finite set x to an onto function or onto function f from x to x is necessarily one to one for every finite set x. Third, the above results not true for infinite set.